All right, this is Unit 5, Lesson 5. In this in this lesson, we're going to learn how to solve systems of equations. You did do this in Algebra 1. You solved systems of linear equations algebraically and graphically. What's different here is we're also going to incorporate quadratic equations. All right, so you're going to see some quadratics, some parabolas, and you're also going to see some equations of circles. Those are the ones where you have both an x squared and a y squared. That indicates that that is a circle. Okay, so we're first going to take a look at how to solve algebraically. Then we'll take a look at solving graphically by hand. And then there's also a component where we are going to be learning how to do some of this on our calculator. Now, I can't pull up the actual calculator on my smartboard while recording. It won't let me do both at the same time. So if you did miss class and are watching this for the first time, please make sure you do come see me to make sure you understand how to do it on the calculator. Okay? All right, so let's get started. So we can use any method we want. There's, excuse me, you learned both substitution and elimination, and it really does not matter to me which method you go about using. Sometimes it's easier one way or another. Sometimes both would work just fine. But the ultimate goal is to eliminate one variable, solve for the other variable that's left over, and then plug it back in. Now keep in mind, for quadratics, typically we have two solutions. So sometimes we're going to have 2 points of intersection. Sometimes we are going to have none. And there is also a possibility to get only one solution if you have two functions that are tangent to each other. Like let's say you have a line that the only place it's crossing a quadratic is at the vertex. All right. So let's take a look at number 1. I'm going to use substitution because I already have both equations solved for y. You could use elimination too, because if you notice, they're set up pretty nicely. So it doesn't matter to me which method you do. But I'm going to go ahead and substitute this 2x minus 2 in for this y. All right, so I've got 2x minus 2 equals x squared minus x minus 6. Now I only have x values and I have an x squared, so I know I'm going to have to solve the quadratic. So from here I can use factoring. Completing the square, I could use quadratic formula. Any of those three would work. Can't use the square root method because I have an x term. So I'm going to first see if I can factor this. So I'm going to move everything to one side. So I have x squared, subtract, and I get negative 3x minus 4. So is that factorable? Do I have two numbers that multiply to negative 4 and add up to negative 3? Yes, I do. I have negative 4 and positive 1. Okay, so those are the factors. So if I set each factor equal to 0 to solve, I get x equals 4 and x equals negative 1. Now I'm only halfway done. Remember, what we're looking for when we're solving systems of lines or quadratics or whatever is points of intersection. Okay, so that's a key thing here. I'm looking for where these two actually cross each other on a graph. Points that I could plug in for x and y that will satisfy both equations. So I have the x value, so now I need to substitute the x back in to solve for the y. It does not matter which equation I substitute them back in for, so I'm going to choose the one that is smaller. I'm going to choose the line to substitute it in one at a time. So I plug in the 4, right, and I simplify and I get 6. And then I'm going to plug in the negative 1, and I simplify and get negative 4. So my final answer will be a set of points, okay, 4, 6, and negative 1, negative 4. Just make sure you match up the correct x and y's. All right, so I see that that quadratic and line do cross in 2 places. All right, let's take a look at this second example. So let's try elimination this time. Okay, so if I just eliminate, I can get rid of my y's. They both have a coefficient of 1. So if I just go ahead and subtracted the two equations as they are, my y's cancel out. Okay, so I could do it this way if I wanted to. If I had a coefficient in front of my y's, I could definitely, still use elimination, but may not. So I get 0 equals x squared. I'm doing negative 2x minus the x, giving me negative 3x. 1 minus a negative 3 gives me a positive 4. All right, so once again, I have a quadratic. So I'm thinking, all right, maybe 2 points of intersection. So let's go ahead and let's solve the quadratic equation. It's not factorable. There aren't two numbers that multiply to a positive 4 and also add up to negative 3. Okay, I can't do it when they multiply to a positive 4. So let's go ahead and try our quadratic equation to solve. So x equals a positive 3, because it's the opposite of b squared minus 4 times a times c all over 2 times a. Okay, so when I simplify it, I end up with this. -7. What does that tell me? Am I going to be getting points of intersections that have i's in them? No. Okay, I can't do that. All right, we know we can solve a quadratic and get imaginary solutions, but remember, we're looking for where two functions actually cross each other. They're not going to be crossing at imaginary points. That's just not possible. I'm looking for real solutions here. So because I solved that quadratic by, or I solved that quadratic and got imaginaries, that tells me that they don't intersect, so there is no solution. All right, and then you can also use your calculator later to check to verify, hey, indeed they don't cross each other. All right, taking a look at our next example. In this one I have this is supposed to be a y squared. Sorry, not a 2y, make that a exponent. I have a circle, okay? The center of that circle is at 0, 0 with a radius of 5, just for a visual purpose. And I have a line, okay, that has a y-intercept of 0. All right, so probably not going to do elimination here because I have x squared and y squared in the top one and just an x and y in the bottom. That would get, can't do it. Okay, so we're going to substitute. So first I'm going to solve for one of my variables. I'll solve for y. Divide both sides by 4. Now I'm going to substitute that back into the y of the original equation. So I have x squared plus 3, this whole thing squared equals 25. All right, so I'm squaring 3/4 x. That's going to give me 9/16 x squared. All right, quadratic we got to solve. Well, take a look at this. I've got x squared and I've got numbers. So I could use a quadratic or complete the square or whatnot, but looking at it, I don't have a middle term in x, so I'm probably going to use just square rooting. So I'm going to combine these. So if I change this, it's 16 over 16, just so I have compatible fractions to add. When I add my numerators, I get 25 over 16, x squared equals 25. Now this is actually going to work out nicely because to isolate the x squared, I've got to divide both sides by 25/16 or multiply by the reciprocal, right? Because that's going to cancel everything out. If I multiply by 16 over 25 here, I just end up with x squared equals 16. All right, whew, that was a nice one. So I can square root each side and get positive or negative 4. So those are my two x values, positive 4 and a negative 4. So now we got to plug them in to find our y. Same thing, I'm going to plug them into the bottom one. That looks a lot nicer, okay? So 4y equals 3 times the positive 4, or 4y equals 12. So y equals 3. And then 4y equals 3 times a negative 4. So 4y equals a negative 12, y equals negative 3. Okay, so my 2 points are, write them over here because I'm running out of room, are 4, 3, and negative 4, negative 3. Good. All right, and then the last one I have algebraically, once again, is a quadratic and a line. So I'm going to substitute, but I'm going to solve. So it doesn't matter which one you solve for. I'll go ahead and solve for y, because why not? Get it? Okay, anyways, moving on. So this is going in place of the y up here. X squared plus negative x plus 6 squared equals 26. All right, FOIL, please do not just distribute that exponent. So this ends up being x squared minus 12x plus 36. Okay, I got that by foiling. Equals 26. I've got an x squared, move everything to one side, and let's factor, or quadratic formula, or whatever you want to do. So 2x squared minus 12x plus 10. So I'm going to pull a 2 out, give me x squared minus 6x plus 5. Two numbers that multiply to 5 and add up to negative 6. That is correct, negative 3 and negative 2. So it tells me my solutions are at 3 and 2. So I've got to plug them back in to find the other value. So if I plug, use a different color. If I plug 3 in for for x, that means y is equal to 3. If I plug 2 in, that tells me my y is equal to 4. So my 2 points are 3, 3, and 2, 4. Okay. Alrighty. Just making sure I did everything properly here. Okay. Graphing. Graph them and find out where they cross. So let's start with the line. Y-intercepts at -2 because of this number here. Slope of 1. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, or down 1 over 1, down 1 over 1. You get the idea. There's my line. The other one is it's quadratic. So a couple ways we could do it. You could transfer it to vertex form if you want, or just find the vertex and use the pattern that we have. Remember, to get the vertex, it's -b over 2a. So it's -4, more commonly known as a positive, over 2 times 1. So the x value of the vertex is 2. Plug it back in to find the y. So I get 4 minus 8 minus 2, which gives me -6. Yes. So my vertex is at 2, -6. Now guys, we've learned the pattern. Our a value is 1. So we can use our basic up and over pattern. There's no dilation here. So up 1 over 1, up 3, 1, 5, 1 in both directions. 1, 2, 3, 1, 2, 3, 4, 5. Oh, hey, look, there's a point. I just drew it. Going in the other direction. And now things aren't always going to cross on pretty points, but this one it did, which is nice. So my 2 points of intersection are at 0, -2, and 5, 3, which if we solved algebraically, we would have gotten the same thing. It's just a different method of doing it. Okay? All right, so once again, if you missed class and this is your first time watching it, please come see me to make sure you know how to do it on the calculator. But whether we solve algebraically or graphically, we are looking for points of intersection, and it is possible for the graphs to never intersect. So in that case, we have no solution. That is all.